Very good afternoon to one and all. So I'm going to discuss about one important topic from module number 6, that is welding. Some of the portions were covered in module 5 too. Maybe at the end of the module 5, these the fundamental topics of weldings were added. So it covers that too. Now let's come to the welding. So it's a very important manufacturing process. So we have learned about the primary manufacturing processes in the first 3 modules. What are the 3 primary manufacturing methods we learned? Can you remember it? Yes, casting. Good. Then rolling, forging. Yeah, all these are referred to as primary fabrication processes, isn't it? Now the welding, which actually I will classify it under or among the secondary manufacturing processes. So when this word welding come to your mind, what would be a welding? Yeah, it's a metal joining technique, or it's a widely used fabrication technique to join two or more metallic components, combine two parts to make it as a single part. Or in other words, more scientifically we can say the products obtained from primary manufacturing processes like casting, rolling, extrusion, forging, etc. Sometimes these components um, will be machined or joined together. Maybe that may be a requirement. Sometimes some products from the primary manufacturing process will be directly used. Sometimes some secondary manufacturing or additional manufacturing process need to be work on it. Maybe sometimes machining or joining. Okay, so all these metal joining techniques come under secondary manufacturing process, and this can be, so this welding is, again I will tell you, it's a permanent joining technique. So before coming to that, the metal, what are the different metal joining techniques? Maybe the mechanical fastening using nut, bolt and rivets. And again, what another joining technique, you know about the bonding, adhesive bonding using glues and resins, isn't it? Yes, welding is of course soldering. Maybe you may have done some kind of soldering, bracing. All these are metal joining techniques. Now, if you look at the joining techniques which I have explained, the fastening as well as the bonding, they are temporary, isn't it? Temporary or semi-permanent joining techniques. But the welding, it's a permanent joining technique. Or in other words, the joint obtained by metallurgical fusion process. അതുകൊണ്ടാണ് അതിനെ permanent joining method എന്ന് പറയുന്നത്. The joint obtained by metallurgical fusion technique. Okay, that means if you look at this code, you can say that in welding, the interface of two metallic components to be joined is heated to a temperature near or above the melting point and the joint is made. So it's a metallurgical fusion process. Now, based on the source of heat input, whether pressure is applied or not, or whether the filler material is used or not, and the type of filler material used, there are more than 50 different welding processes are used nowadays in many industries. Okay, so let's classify the major groups of welding processes. So let's classify. First of all, let's broadly classify the welding processes into two important categories called fusion welding and solid state welding process. I will explain you in detail what is all about. So we can broadly classify into fusion welding and solid state welding processes. So what is shown in this picture is a schematic representation of different welding process, say arc welding, resistance welding, gas welding, solid state welding, other welding processes. Maybe we are going to cover all or some of the very important welding techniques in this module. So these are the major themes which we are going to discuss, that is arc, resistance, gas, solid state and other types of welding processes. Now let's give a definition to this welding. That would be nice if you can give a scientific um, definition to describe the welding process. So I can tell it's a localized coalescence of metals obtained by heating to a suitable temperature. What was the temperature? I already explained, melting point. With or without application of pressure and with or without the use of filler material. So that is a formal definition of welding. A localized coalescence of metals where the coalescence is obtained by heating to a suitable temperature with or without application of pressure and with or without the use of filler material. So the, the welding which produces a strong solid connection between the two pieces, and that joint is called as the weld joint. You must know about all the terminologies. Okay, so that is called a weld joint. So the product obtained by the process of welding is known as the weldment. Okay, so that's called the weldment. Then what do you mean by a base metal? Base metal refers to the pieces of metal which are being welded to form the welded joint or weld joint. That is called the base metal. Now let's look into different types of welded joints. Actually, the weld joints can be classified into 5 different types known as the butt, corner, lap, T, edge. These are the 5 basic types of weld joints. All these types are illustrated here. Now let's see uh, what each type of joint means. Actually, the relative position of the two pieces being joined when you are going, if you are going, the metal joining is possible when then there is two work pieces need to be there, isn't it? You are going to join these two work pieces to get the final joint. So in butt joint, if you look at the diagram, you can see that the parts are placed in the same plane and joined along their edges. That is called a butt joint. In the case of a corner joint, the parts in a corner joint are kept at right angles and are joined at the corner of the angle. In a lap joint, the parts are kept overlapping each other and the joint is made between the edges of one part and surface of other part. Edge of one part and the surface of other part. Isn't it? If you look at the diagram, you can easily understand this. In the case of a T joint, the parts are kept perpendicular to each other, forming a T shape. And the joint is made along the contact area between the two parts. The parts in an edge joint are kept parallel and one of the common edges were welded. So these are the different type of weld joints: butt, corner, lap, T and edge. Again, if you look at the welding positions, So we have discussed about the five different or five basic types of weld like butt, lap, corner, T and edge. Now these types of weld joints can be made in any of these forms explained here like flat, vertical, horizontal or overhead. Okay, now this is how the welding is made. You can do a flat welding, vertical, horizontal as well as overhead. All these represents the different welding position to obtain a weld joint. And then what are the type of weld? So the two common type of weld are fillet weld and groove weld. What do you mean by a fillet weld and a groove weld? So a weld of approximately triangular cross section is called a fillet weld. A weld made by groove between the workpieces is called a groove weld. So fillet weld and groove weld. So in corner, lap and T joints, നമ്മൾ 5 തരത്തിലുള്ള welded joint ഉണ്ടായിരുന്നു. Butt, corner, lap, T and edge. Among that, in corner, lap and T joints, the fillet weld is used. That is triangular cross-sectional weld. So the advantage of using this is the minimum edge preparation is needed and the filler metal is used to create the cross-section approximately of a right angled triangle. So that is what is shown in this picture. You can see a corner, lap and T-joint made by fillet weld is shown in this picture. Whereas in the case of groove welds, the edges of the part need to be prepared. The preparation is very much needed in the case of groove welds to the shape of a groove. You can see this in this picture. So what is shown here in the case of a butt joint, you can see that how the different type of grooves are obtained. You can see, sorry, you can see this. You can see a square shaped, a bevel shaped groove, here a V shaped groove, here a J shaped groove, a U shaped groove. So you need to machine in order to get these type of grooves. So fillet welding the case the preparation is very less preparation is required. You can do a that can be easily welded. But in the case of groove welding, you need to prepare the edges such that the groove has to be made. Okay. Similarly, square, single bevel, single V, single J, single U, and similarly on both sides, double square, double V, double bevel, double U, type of welds can be produced. Then another important title called weldability. What does you mean by weldability? So it is the capacity of the metal to be welded to a suitably designed structure and to perform satisfactorily the intended service. So the capacity of the metal to be welded into a suitably designed structure. അതിനാണ് weldability എന്ന് പറയുന്നത്. So weldability is always associated with a metal. The weldability of copper will be different from steel, will be different from brass, different from bronze. So what does it represent? It is the capacity of the bronze to be welded to a suitably designed structure or copper to be welded to a suitably designed structure. That's called the weldability. So weldability of copper, weldability of steel, the capacity of that metal to be welded to get a suitable structure. Let's see what are the different uh, factors which affect the weldability. One is the welding process. Which type of welding process? Arc welding, solid state welding, resistance welding. Which type of welding process we are going to use? The properties of the base metal, the element which constitute the base metal. Of course, that determines the properties of base metal. Then properties of the filler metal. If you are using any filler metal, that properties will affect the weldability. Then surface conditions. All these factors that will be affecting the weldability. For example, some metals can be easily welded, but some other metals or alloys can be is difficult to weld. For example, the aluminium, it can be it can melt easily and is suggested as one of the nice metal for welding. However, the copper, which is having high thermal conductivity, and the heat is transferred faster from the weld zone, so making it's difficult to make a weld joint. Okay, now when you are dealing with the welding process, it's very important to understand the solidification of weld metal. So actually, there are three distinct zones can be identified in a welding process. Especially, um, you know that after a suitable welding process, you will get a weld joint, isn't it? Maybe, for example, the case of a fusion welding process, the weld joint obtained from a fusion welding process, it generally has three zones. One is a base metal, a heat affected zone, or it is popularly known as HAZ. Very important. Base metal, heat affected zone, and weld metal. If you look at the diagram which is shown below, you can easily see that the zones are marked here. You can see the unaffected base metal zone. Unaffected means the base metal zone which is unaffected by the heat of welding. Then heat affected zone, the zone which is affected by heat. Fusion zone, of course, this is a zone where the actual melting of base metal, or if filler metal is used, that actual melting and fusion is taking place here. So three zones. Okay. So the if you are going to use a filler metal, the central zone, that is the black region, this region, it consists of a mixture of both base metal and the filler metal. Okay. Sometimes if it is if there is no when no filler metal is used, of course this central zone or this black zone is composed of the base metal only. Okay. You know well that during this welding process, yeah, intense heat is required depending upon the melting point of the metal to be welded and joined. Intense heat is required. And this intense heat actually which will melt the base metal, if filler metal is there, which actually melt the base metal and filler metal in the fusion zone. Okay, fusion zone. And what we'll do then after doing that, we allow to cool down to the room temperature and solidify. So which means, just like in the case of casting, the solidification process is similar here. Which means, if you look at the diagram just below, which shows the grain structure, you can see that the columnar grains, we can see that in the central zone the columnar grains are formed, which means that grow parallel and opposite to the direction of heat flow. Okay, you know that the heat flow will be downwards, and the columnar grains which are have grown horizontally. Okay, so what I can say that in general the weld metal has a cast structure having coarse grains. Why it is having coarse grains? Since the cooling occurs very slowly. So as a result, the weld metal has very low strength, toughness, and ductility values. And how you can modify these properties? Of course, by using a proper filler material or by doing appropriate heat treatments. All the heat treatment techniques like annealing, normalizing. By doing those techniques, you will be able to improve the mechanical properties. Okay. Now, if you look at the diagram again, you can see that at the central zone you will get how columnar grains, and in the heat affected zone, you are getting finer grains, comparatively finer grains, and in this region you will get original cold worked grains. Okay, this is how the grains would be look like. Fine grains are given, and comparatively, though this is fine grains, comparatively less compared with the base metal columnar grains. So three zones I would end on the fusion zone, HAZ zone, and base metal zone. Now again, this heat affected zone. This is one of the very important zone which you need to be studied in detail. Okay, why? Because during this welding process, some portion of the base metal is heated to a higher temperature, not to the melting point, just below the melting point. Actually, above the melting point takes place at the central zone. Okay, so below the melting point and then slowly cooled. So this region of base metal is called the heat affected zone or HAZ. And because of due to the heating and cooling, this microstructure of this region changes, or the region which will be subjected to microstructural changes, or microstructural changes happen to this HAZ region. As a result, what will happen? The properties will change. But please note that the region, that is the base metal, which is away from this heat affected zone or away from the weld zone, it's not undergo any changes. And you know well that when the microstructural changes happen to a particular region, the mechanical properties will change. Okay, so depending upon the temperature up to which it is heated and cooled, the properties change. So this zone, heat affected zone, plays a very important role. So most of the weld researchers will look into this region very closely. They will do all types of analysis, like they will do a hardness testing, they will do a tensile testing, they will do a microscopic evaluation. All type of evaluation will be done to see what type of weld zone, the heat affected zone is existing for that particular material. Okay, and as I told you, the mechanical properties of this heat affected zone depends on how these properties were developed prior to welding. For example, when you are going to weld a cold worked metal, when you are going to apply the heat, that heat leads to the recrystallization of the grains of elongated shape. For example, the grains closer to the weld metal will grow into coarse and soft grains, which I have explained earlier, while those away from the weld metal recrystallize into fine equiaxed grains, which you have seen this here, isn't it? The grains in the fusion zone is columnar, whereas as it moves away from this fusion zone, it becomes finer and finer. So it's not that heat affected zone is very important. Thank you.